Transformations of parent functions. The graph of a function can be transformed by either shifting, stretching, shrinking, or reflection. The elementary transformations of a function f are captured in function notation as follows. Translation. Shifting up or down is given by f of x plus k. Shifting left or right is given by f of x minus h. In this case, k is outside of the parentheses, and here, negative h is inside of the parentheses. Reflection. Over the x-axis is given by negative f of x. Over the y-axis is given by f of negative x. Here, the negative sign is outside of the function, and here it is inside the parentheses. Distortion, which is covered along with each function. To stretch or shrink vertically is given by a times f of x. To stretch or shrink horizontally is given by f of b of x. In this case, a is outside of the function, and in this case, b is inside of the parentheses. Shifting the graph of a function f of x up or down is given by f of x plus k, and is called a vertical translation. If k is greater than 0, then the graph of f of x shifts up k units. If k is less than 0, then the graph of f of x shifts down k units. Consider f of x equals x squared, this blue graph here. Two of its translations, plus 2, so g of x, the red graph, is f of x plus 2, and h of x, the green graph, is f of x minus 3. The graph g is the result of when f moves up 2 units, so 2 units up, and then all of a sudden we have g. The graph h is the result of when f moves down 3 units, so 1, 2, 3, and that's h. Use the function g of x equals the absolute value of x for each problem below. Write a rule or formula for the new function after the given translation. So, what formula will shift the graph up 7 units? That would be g of x plus 7. So that would be the absolute value of x plus 7. Shifts the graph down 5 units. G of x minus 5. Absolute value of x minus 5. Shifts the graph down 8 units. That would be g of x minus 8, or the absolute value of x minus 8. Shifts the graph up 10 units. G of x plus 10, or the absolute value of x plus 10. And there we go. Use the function f of x equals x squared plus 2x for each problem below. Write a rule or formula for the new function g of x after the given translation. Shifts the graph up 11 units. So that will be f of x plus 11. So that means g of x is going to equal x squared plus 2x plus 11. Shifts the graph down 2 units. So f of x minus 2. G of x will equal x squared plus 2x minus 2. Shifts the graph down 6 units, or f of x minus 6. That makes g of x equal to x squared plus 2x minus 6. Finally, shift the graph up 3 units, f of x plus 3. That gives us g of x equal to x squared plus 2x plus 3. And there we go. Shifting the graph of a function f of x left or right is given by f of x minus h, and is called a horizontal translation. If h is greater than 0, then the graph of f of x shifts right h units. If h is less than 0, then the graph of f of x shifts left h units. Consider f of x equals x squared, here in red. Two of its transformations, blue we have g of x, and that is f of x plus 2, and h of x, over here in yellow, f of x minus 3. The graph g of x is a result of when f of x moves left 2 units. The graph h of x is a result of when f of x moves right 3 units. So it's a little counterintuitive. When you see plus 2, inside the parentheses, that actually means to the left 2. And when you see minus 3, that means to the right 3. Use the function f of x equals 1 over x plus 3 for each problem below. Write the rule or formula for the new function after the given translation. Shift to the left 2 units. So we're going to take f of x, and it's going to be f of x plus 2. So then we're going to take this and plug it in to our new formula g of x, which is going to be 1 over x plus 2 plus 3. Shift to the right 4 units. That will be f of x minus 4. So g of x is going to equal 1 over x minus 4 plus 3. Shift to the left 7 units. F of x plus 7. G of x equals 1 over x plus 7 plus 3. Finally, we have shift to the right 9 units, or f of x minus 9, giving us g of x equals 1 over x minus 9 plus 3. And there we go. Translation of piecewise functions. Let f be a piecewise defined function displayed in red below. So we have these 2 little segments here and here. 2 of the translations are shown. Shift f down 4 units to get g. So you would take every piece of this piecewise function and shift it down. So this red piece here shifts down 4 units to this green piece. This red piece shifts down 4 units to this green piece. Shift F to the right 3 units to get H. So we would move this little segment to the right 3 units, and we'd move this little segment to the right 3 units as well. So we have g of x equals f of x minus 4 because we're shifting it down. The domain is the same as it was before because we're just shifting it down. We're not changing the x values. But however, the range has changed. Now it's from -6 down here to -4, not including -4. That's why it's parentheses. And it's also -3, including -3, bracket, up to -1. And here, we've changed the domain, but not the range. Note, the domain will change for horizontal translations, and the range will change for vertical translations. Let f of x equal x squared for x that is greater or equal to -1 and less than or equal to 2. Write the rule or formula for the new function after the given translation. All right, so for g, we're shifting it to the right 3 units. So we'll take f of x minus 3. So that's going to equal x minus 3 squared. This is our new rule. Now, for h, we're going down 4 units. So that's going to be f of x minus 4, which is going to equal x squared minus 4. As you can see, when we move f to the right 3 units to create g, the domain has changed. Now the domain is from 2 to 5 instead of from -1 to 2. When we shift down, the domain remains the same. The domain of f of x is -1 less than or equal to x less than or equal to 2. This means the domain of f of x minus k, like here, is -1 less than or equal to x minus k less than or equal to 2. So all we have to do is put a -k in here, and then you can move this k, you can add k to each portion. You add k through the inequality, so we add k over here, that becomes -1 plus k. Then we're left with just x in the middle, and we've added k over here as well, so that becomes 2 plus k.